All right, so today, ladies and gentlemen, we are going to be doing M7, lesson 8-10. And this is primarily focused on this concept called volume. Okay, to give you an idea of volume right off the bat, I want you to imagine a bathtub. Yep. Okay, that's a really nice bathtub. It's a jet tub. And we're going to put some water in this tub.
Make it yellow.
Okay, no, I'm not doing that. There's going to be no yellow water in this tub.
That's purple, Mr. B.
Oh, it's cool.
It's purple. See, it's purple. It's not a shell. It's purple. It does look like a little bit. No, it doesn't. No, it's red. Wait, no, now that's
Okay.
purple.
Well, you know what? It's a lot bluer on my tablet than it is on the screen. So, there it is. Okay, here's our tub. Now, listen. Let's say that this tub was pretty full, and I decided to drop a baby elephant in it.
Damn, do something against baby elephants. What is that?
And since this baby elephant...
I'm a full elephant for your information.
I can't get all of the elephant in the picture here, so we're just going to get a little bit. It's going to be part of an ear.
That is so cute.
You can take a picture of me.
What? Oh, do you want to scroll this? Did you take art school or something?
Okay, so yeah, there's actually a... Well, elephants are very wrinkly, so... Okay, so there's a baby elephant. I'm going to drop the baby elephant into the tub. Okay, so I can't get all of the baby elephant in the picture, but here we go. All right, now in all seriousness, ladies and gentlemen, what would happen to the water? Okay, Jacob?
It would splash.
Okay, it would, I'm not going to say splash, because we'll ease the elephant into the water. Okay, the water...
We have to draw an elephant.
No.
Are you serious? Draw a big ball.
All right, stop. Mr. Miller, the water would flow out. Why? Why wouldn't the water just go around the elephant and stay in the tub?
I know.
Hang on, I'm going to give him a chance to answer this. This is really important idea here about what we're looking at with solids. It is, but why does it flow out? What does the elephant do? Okay, you're on the right track. Let's not use mass though, because the elephant's really heavy, sure. But what if we had a styrofoam elephant the same size? Let's just say that we pushed it into the water. Would the same amount of water flow out?
No. It would flow on top.
I said it can't. I said we'd push it into the water.
Would it be the exact same size?
Exact same size.
It would be the exact same water flowing out.
It'd be the exact same water flowing out. So we know weight has nothing to do with it. It's the size of the object. The size of the object that takes up what?
Volume. Mass.
Space and volume. Okay, so here's the big picture. Every object takes up space. I think that's a pretty easy idea for us. We take up space. Right now, instead of there being air where I'm sitting, I'm taking up this space. If I move, what's going to fill in behind me? Air. You're right. Air is taking up space. Air is filling everything in this room where there isn't another object. All right, so this chair, the chairs take up space, but if I were to take all the chairs out, what would replace it?
Air.
Air. Okay, so that's the main idea here. That's where we're going with this. All right. Now, ultimately, we are going to be talking about the volume or the amount of space of two different types of objects. Okay, two different types of objects. So I'm going to kind of lay those out. The first one is a prism. And we're going to talk about the amount of space prisms take up. And we're also going to be talking about cylinders and the amount of space cylinders take up. And the big idea, the amount of space, we give it a very special, it's a very special word. It starts with V. It's called volume. Not to be confused with like how loud something is. All right, volume is the amount of space something takes up. And we're going to be looking at these two things specifically today. Noah?
It's like space, like out of the world space. If like something moves, what replaces it?
That's a great question. In outer space, when something moves, nothing replaces it. That's why, hey, Noah, that's why objects in space can go on forever, because there's nothing to slow it down or there's nothing to move around it.
Isn't that another reason why we can't breathe?
Well, that's another reason why we can't breathe in space.
Plus no oxygen.
Wait, then how does?
All right, I don't want to get off topic.
What would happen if you open an oxygen tank and let it into space? Would it explode?
And let's move on for a minute here.
Wait, where does the air go if you open it like an oxygen space?
Draw Draw a little kind of rectangular square right there. And I'm going to go up a little bit. I'm going to draw the same thing. That's a great question. Nope. Nope.
You're just making two rhombuses, but look like they're on top of each other.
Right, exactly. I'm freehanding this, so you guys can do the same thing. And I got to put a dotted one in the back there. Not exactly. Just keep trying.
You like my elephant?
Keep trying. All right.
Elephant.
Parker. All right, and then draw a cylinder as well. I think cylinders are easier to draw.
Same.
Sometimes it takes practice. The ticket is to draw the same object on the top and the bottom. So we have prisms and cylinders. And we want to find the amount of space they take up. Okay, the amount of space they take up. Okay. So here we go. Let's imagine for a moment that on our prism we had one layer okay, that was one tall. Okay, I'm going to zoom in on this a little bit so it's easier to see. So I had one layer. You don't have to draw this. I wanted you to practice drawing the original figures. Hey, no, you still had to draw the originals. You just don't have to draw the layer. Okay, if you did, that's fine, then leave it. Okay. Let's draw it one layer, one tall. Let's make this 4. Let's make this 2. Okay, that layer is going to be kind of like its own piece of the puzzle, being only one tall. Like so. Okay, so there it is. There's the piece of the puzzle. And it's 4, 2, and 1 tall. I'm just drawing it. I want you just to watch. Okay, I just don't worry about drawing. Just watch. All right, what would be the volume of this piece of the puzzle? What would be the volume of that? What would it be?
7.
No. Yeah.
8.
It would be 8 units, and because it's volume, it's actually going to be units cubed. Okay? Well, if you want to find, let's say, the area of the volume of a cube, you do base. Or actually, let's do this.
Base times.
You do length times width times height. Length, width, and height.
Because the 1.
So we end up with 4 times 2 times 1.
Equals 8.
4 times 2 times 1.
Me too.
8 units cubed.
There's a 3?
Yes.
Okay.
So all the ones that we have to do tonight, we have to put units cubed.
Yep. Now,
But inches cubed.
okay, I added another layer. What can you tell me about the bottom layer and the next layer?
They're both the same.
They're the same dimensions. They're both 4 wide, they're both 4 long, 2 wide, and 1 high. So what could you tell me about the second box? What would be its volume? Anna? It would also be 8. Okay? So I know that the bottom one has a volume of 8. I know that the next one up has a volume of 8. What about if I added another layer here that's 1 high as well? What would its volume be? Elizabeth Lawan?
8.
It would also be 8. Let's add another layer.
This looks really cool.
And what can you, and it's 1 high. And what would its volume be?
8.
8.
I'm so smart.
Oh, I don't want to do that. And I'm going to go last but not least. I'm actually creating 2 here because okay, and so there's 1 here and then there's 1 there. All right, I know each layer has a volume that's 8. How many layers do I have? Savannah? I have 6 layers.
6 times 8. Oh,
Really, Jacob?
I raised my hand.
6 layers. Each layer has a volume of 8 units cubed. So that's like saying 6 times 8 units cubed. Jacob, what's 6 times 8? Caitlin? It'll be a total of 48 units cubed. It's like adding up all the layers. But I've got a little bit of a shortcut for you. Okay, you don't have to do this for every problem. What if I were to have taken the 4 times the 2, and instead of adding up every layer, I just said that the bigger object has a height of 6. What's 4 times 2 times 6? 48.
Nice job, Jacob.
So ultimately, it doesn't matter. It's like I'm taking an object and adding up all the layers when I go ahead and I multiply by heights other than 1. I had 6 layers or I had 1 layer 6 high. It doesn't matter.
What if it doesn't tell you that 6?
It will. It will.
Oh, yes, it does.
We don't have to necessarily, no, you don't have to find the 6 layers. I'm just kind of teaching you the idea here. Okay, so here's what we did. Stop. No, listen. I found 4 times 2. Isn't that the base area?
Yeah.
It is. It's the 4 times the 2. I found the base. And I multiplied the base area, the 4 times the 2, by the height. That's how I found volume.
All we did.
That's all you do. The base area times the height. So,
That's why you made us go through the whole chapter.
shh. How do I find the base area of a cylinder? What is the base area of a cylinder? What shape is that? Yeah, it's a circle. Okay, so if I find the area of the base and I multiply it by the height, I can find the volume of this cylinder.
The whole thing?
Okay, the whole thing. So, this is the radius, and let's say that the radius of this cylinder is 3, and the height is 8. How do I find the volume of a cylinder? Savannah?
You would do. What do you define the circumference first?
Not the circumference. What am I finding? The base. Look up there. The base
Area.
area.
So you'd find the circle.
I would find the circle
And I
area.
know how to do it.
Do you remember the formula?
Yeah.
What is it?
Pi r2 squared.
Pi r squared.
Yeah, that's what I meant.
I know.
No, that's fun.
Okay, that's the base area. Caitlin, where are you at? Caitlin, what's the radius? It is. It's 3. Okay, so I'm going to actually move this. Okay, the base area is pi r squared. Caitlin's right. It's going to be pi times 3 squared. Does anyone know what, Isabella, what's 3 squared?
9.
Okay, so this is going to be 9 pi. We could leave it like that, like we learned yesterday, or
28.26.
or it's 28, let's say 0.3, roughly. Okay, then I find the base area, like I did over here, the yellow part, and I multiply it by the height. What's the height of my cylinder here? Isabella?
8.
8. So I would take the base area and I multiply it by height. So I take my 9 pi and I multiply it by 8, or I can take 28.3 and multiply it by 8. I'm going to get the same answer either way. All right, what's 9 times 8? Caitlin? 72. So this is going to either be 72 pi, or what's 28.3 times 8? 160, 204, 250?
Did you just do 72 divided by 2?
226.4.
Got it.
What is it, Jacob?
226.4.
All right, so that would be the volume. Now, this is going to be the last. Mackenzie Berg. Look at the units for my prism. Okay, it's units what? Cubed. Very good. And that's a really good word to use. Cubed. Units cubed. All volume, no matter what object you're looking at, are going to have units cubed. So, if my answers for these problems are 72 pi or 226.4, what do I have to add to those to make it a correct answer? Jacob? Units cubed. Both of those answers are acceptable. And actually, both of them are equivalent. Both of them are equivalent. Let's try 2 on our own, because I know that this is a little bit more difficult of an assignment. Okay? This time, I'm actually going to give you your equations to work with. And I want to make sure that they don't give you any funky. Well, they do give you a little bit of a funky one in your homework. So let's look at that. Yes. Because when you're doing volume, when you're dealing with volume, you're dealing with 3 dimensions. So 3 units multiplied by each other is units cubed. When you're dealing with area, you're only dealing with two things, like length and width, or like. Right, that's 3 things. It'd be cubed. All right, let's work with. I want you to write these down. You don't have to draw them, but you do need to label them. We are going to go with triangular prisms. We are going to go with rectangular prisms. Units cubed. Yep. No. If you see the word volume, think cubed. Volume, cubed. Area, square. Volume, cubed. Area, square. The base area is going to have, but then you're multiplying it by another thing, Gretchen. So you're taking an area and you're multiplying it by one more thing, the height. So it's like having an area, which is already squared, and multiplying it by a height, so it's another thing. Yeah, Savannah.
A good way to remember that is when you're doing area, it's base times height, that's 2.
Right.
And when you're doing volume, you do length times width times height, that's 3. So you put a 3 on it.
Yep.
What's the
Bam.
what's it called? Equation and like the thing on the for cylinder.
Find what? The volume or the area?
Actually, I don't want to do that.
But then you gotta find the length.
Ah, having a hard time here. There we go. Okay. I'm drawing a triangular prism. Like so. I'm going to draw a rectangular prism as well. And I'm going to draw a cylinder. I bet. Yes, we did, Parker. We're not. I'm giving you a sheet of formulas.
That's a good idea. Yeah, I got a good formula.
Because it's running through the internet.
Parker, you're a genius.
I don't want you necessarily to draw the figures, but if you want to, that's a great idea. That's great then. Okay. Here's the thing about prisms, cylinders. All right? Notice that I've colored the base of each one of them. Okay? This right here is the base. And it has an area. And then over here, this is a base. And it has an area. And then over here, this is a base. And it also has an area. But each one of them is a little different. How do you find the area of a triangle? Yes. Yep, so we do 1/2 the length times the width, or the base times the height. So I'm going to call this back here, this is a right triangle, I'm going to call this the length, and that right there the width. Notice that's 3 dimensions. Okay? Then you take that base area and you multiply it by height. So you take that and multiply it by height. I did not. Notice my letters. I used L, W, and H. On a rectangle, the base area is just the length times the width. And then you would just go ahead and multiply that by height. So over here, you'd have length, width, and height. So the volume equals length times width times height. That's by far the easiest one. You're just measuring the 3 sides. Over here, it's a little bit more complicated because you have that triangular base. So volume equals 1/2 the length times the width times the height. Now the base area on a cylinder is, as Savannah had said, it's pi r squared. And then you multiply that by height. So the volume is going to be pi r squared times height. So in theory, I have 3 formulas. I have one for cylinders. I have one for rectangular prisms. And I have one for triangular prisms. There's 3 of them. Jake. Yeah. You have to find the volume, you need to use the base. Mm-hmm. Mm-hmm. We're going to do one problem in class together because we have just a little bit of time. Okay? I know we have 1 minute, and this next problem won't take that long. Well, you're going to stay here until we're done with this problem. I know it did. And here it comes again. Okay, here we go. Let's work through this one problem. This is number 9 in your book. You're right. Okay, this is what it looks like. I do.
I don't know how to draw this. Yeah, stretching. Congratulations.
And they tell me this is 2. Just try drawing it. Wow, that's quick.
Wait, Mr. B.
Yes. Good. Not bad. It's not bad at all. Okay, shh, listen. Okay, here we go. The base areas. This is the base of my prism because it's the triangle. And the other base is right here, like so. Those are my bases. All right. I know that the height in the back is the same as the height in the front, so I'm going to put a 2 right there. right, Isabella? Isabella, we have a triangle right here. We have a triangle right here. What is the area of that triangle? How would I find it? Okay, I would take half the base of that triangle times the height of that triangle. So to find the area of the base, I'm going to do 1/2 what? Isabella? Times 2 times 7. What does that equal? Caitlin? It equals 7. Okay, now, we just did the first part right here. What's the last part that we have to do, Isabella? Times height. And in this prism, the height is the distance between the bases. What number haven't we used yet? 4.5. So we are going to take that 7, which is the area of this base, and we are going to say that it's like going this distance 4.5. So 7 times 4.5 gives us what as an overall volume? 31.5. And Jacob, what are the units? Squared or cubed? Cubed. Very good, Gretchen and Savannah. You're right. It would be inches cubed because the problem is in inches. I had forgotten to write it down, so I just went units cubed. Units. I would be okay with that because you're showing that you at least know that they exist. That's okay with me. Your homework I gave you at the beginning of class. Shh. Stop. I want